Section: Introduction. In this section, we will provide an overview of AutoDev's design and capabilities. Once we have completed the initial setup, AutoDev categorizes its functionalities into four main groups: the Conversation Manager, the Tools Library, the Agent Scheduler, and the Evaluation Environment. Let's delve into each of these capabilities in more detail. We begin by configuring rules and actions using YAML files. These files outline the commands that AI agents can execute. Users have the flexibility to use default settings or customize permissions by enabling or disabling specific commands, tailoring AutoDev to their requirements. This configuration step allows precise control over the AI agent's abilities. Users can define the roles, responsibilities, and actions of each AI agent. For instance, they can designate a developer agent and a reviewer agent to collaborate on a task. After setting up the rules and actions, users specify the software engineering task to be carried out by AutoDev. For example, users can request the generation of test cases, ensuring they are syntactically correct, bug-free, and pass all tests. This process involves editing files, running test suites, performing syntax checks, and identifying bugs. The Conversation Manager is crucial for managing the conversation history. It oversees the overall conversation flow, deciding when to intervene and facilitating communication between the user, AI agents, and the system. The Conversation Manager maintains a record of messages exchanged between AI agents and the outcomes of actions performed in the evaluation environment. Section Summary. In this section, we introduce AutoDev, an autonomous AI coding assistant that enhances productivity by enabling AI agents to perform various development tasks directly within the repository. AutoDev bridges the gap left by existing AI coding assistants integrated into IDEs by offering features like Conversation Manager, Tools Library, Agent Scheduler, and Evaluation Environment, allowing for autonomous execution of complex software engineering tasks. Through evaluations using the Human Eval dataset, AutoDev demonstrates impressive performance in code generation and test case generation tasks, achieving high pass-at-1 scores of 91.5% and 87.8% respectively, showcasing its effectiveness in automating software engineering tasks securely and efficiently. Section: Parser. In this section, we interpret the responses from agents using the parser. The parser extracts commands and arguments in a specific format, ensuring they are correctly structured and validating the number and accuracy of arguments. If there are parsing errors, we inject error messages into the conversation to prevent further actions. Successfully parsed commands undergo further analysis to enforce agent permissions and conduct semantic checks to ensure actions align with user-specified permissions. If the command passes scrutiny, the Conversation Manager triggers the corresponding action in the Tools Library. The Output Organizer module processes the output from the evaluation environment, selecting important information like status or errors. It can also summarize relevant content and add a well-structured message to the conversation history, providing the user with a clear record of AutoDev's actions and outcomes. The Agent Scheduler coordinates AI agents to achieve user-defined objectives. These agents, with specific personas and sets of commands, work together to perform various tasks. The scheduler uses collaboration algorithms like round-robin, token-based, or priority-based to determine how agents contribute to the conversation. The Agent Scheduler selects a specific agent based on the ongoing conversation. Agents, including large language models, LLMs, like OpenAI GPT-4 and small language models, SLMs, optimized for code generation, communicate through natural language. They receive objectives and conversation histories from the Agent Scheduler and respond with actions based on rules and actions configuration. Each agent, with its unique setup, contributes to progress in achieving the user's objective. The Tools Library in AutoDev offers a range of commands for agents to perform operations on the repository. These commands simplify complex actions behind intuitive structures. For example, commands for file editing, retrieval, build and execution, testing and validation, Git operations, and communication empower agents to interact with the codebase effectively in the collaborative development environment. Section Summary. In this section, we summarize the key components of AutoDev's architecture. The parser module interprets and validates commands from users. The output organizer structures and summarizes results. The agent scheduler coordinates AI agents, and the tools library offers a variety of commands for agents to interact with the codebase efficiently. These components work together to enable seamless communication and collaboration among agents in achieving user-defined objectives within the development environment. Section: Evaluation Environment. In this section, we set up an environment called the evaluation environment that runs in a Docker container. This environment allows us to safely carry out tasks like editing files, retrieving information, building and executing code, and testing. It simplifies the process for our agents by handling low-level commands and sending the results to the output organizer module. When we start a conversation, we define the goal and settings. The conversation manager then creates a conversation object that combines messages from AI agents and the evaluation environment. This conversation is then sent to the agent scheduler, which coordinates the actions of the AI agents. The language models, large or small LMs, act as AI agents by suggesting commands through text interactions. These commands cover various functions like file editing, retrieval, build and execution, testing, and Git operations. The conversation manager parses these suggested commands and sends them to the evaluation environment for execution within a secure Docker container. The outcomes of these commands are seamlessly integrated into the conversation history, driving further iterations until the task is completed, user intervention is needed, or the maximum iteration limit is reached. AutoDev is designed to systematically and securely orchestrate AI agents to handle complex software engineering tasks autonomously and under user control. In our empirical evaluation, we aim to test AutoDev's abilities and effectiveness in software engineering tasks to see if it can improve an AI model's performance beyond basic inference. We also want to understand the cost of using AutoDev in terms of steps, inference calls, and tokens. To answer our research questions, we first evaluate AutoDev's performance in a code generation task using the human eval dataset in Python. This dataset consists of 164 programming problems with function signatures, docstrings, code bodies, and unit tests. We measure AutoDev's effectiveness using the pass at k metric, where k is the number of attempts made. A problem is considered solved if AutoDev generates the code for the method's body that passes all human-written tests in the first attempt. We compare this approach with others like directly using GPT-4, which usually involves a single inference call. We focus on pass at 1 for this evaluation. For the test generation task, we modify the human eval dataset to assess AutoDev's ability to generate tests. We evaluate the success of the generated tests, their coverage, and if they correctly invoke the method under test. We also compare the test coverage of AutoDev with human-written tests. In the efficiency evaluation, we analyze the number of steps, inference calls, types of commands used, e.g., write, test, and the total number of tokens used in the conversation to understand how efficiently AutoDev completes software engineering tasks. For this evaluation, AutoDev is configured with one agent based on the GPT-4 model, GPT-4-1106 preview, and can perform actions like file editing, retrieval, and testing. Communication commands like stop are allowed, but others like ask are disabled, requiring AutoDev to operate autonomously without human intervention beyond goal setting. In our empirical results, we compare AutoDev's performance in a code generation task with other approaches like language agent tree search, LATS, and reflection using the human eval dataset. AutoDev achieves a pass at 1 rate of 91.5%, ranking second on the human eval leaderboard without needing additional training data. This result shows a significant improvement over GPT-4 and highlights AutoDev's ability to enhance the performance of language models in software engineering tasks. Section Summary. In this section, we introduce the evaluation environment, which operates within a Docker container to securely execute various commands like file editing, testing, and execution, simplifying interactions for agents. The evaluation environment interacts with the Output Organizer module, while the Conversation Manager coordinates messages between AI agents and the evaluation environment for seamless task completion. AutoDev orchestrates AI agents systematically within a secure environment to autonomously handle complex software engineering tasks, as demonstrated in our empirical evaluation focusing on AutoDev's effectiveness in code and test generation tasks, and its efficiency in task completion. Section: How effective is AutoDev in test generation task? In this section, we examine how effective AutoDev is in the task of generating tests. We compared AutoDev with the zero-shot GPT-4, baseline, and human-written tests in the test generation task. AutoDev achieved a pass at one score of 87.8% on the human eval dataset modified for the test generation task, showing a 17% improvement over the baseline that used the same GPT-4 model. The tests generated by AutoDev had a coverage of 99.3%. Similar to the coverage of 99.4% for human-written tests. When considering the entire dataset of test cases, AutoDev achieved an 88.8% coverage for the focal methods. These results demonstrate AutoDev's effectiveness in handling various software engineering tasks. Moving on to the efficiency of AutoDev in completing tasks, we analyzed the number of commands used for both code generation and test generation tasks. On average, AutoDev executed 5.5 commands for code generation and 6.5 commands for test generation. These commands included write operations, test operations, stop operations, indicating task completion, retrieval operations, syntax check operations, and communication commands. Incorrect commands, such as those involving natural language mixed with code or commands, were also observed. AutoDev's conversations to solve each problem consisted of around 1656 to 1863 tokens, while the baseline zero-shot GPT-4 used fewer tokens. Despite using more tokens, AutoDev allocated them for testing, validation, and explanation of its generated code, surpassing the baseline approach. During a test generation task, AutoDev demonstrated its capabilities by generating PyTest test cases and self-evaluating its output. It successfully corrected errors in the test file and communicated its actions throughout the task. AutoDev's design prioritizes security in executing and validating AI-generated code within a Docker environment. Section Summary. In this section, we compare AutoDev's performance in test generation with the zero-shot GPT-4 baseline and human-written tests. AutoDev achieves a pass at one score of 87.8% on the human eval dataset, showing a 17% improvement over the baseline. It also attains a robust test coverage of 99.3%, similar to human-written tests, and achieves an 88.8% coverage over the complete dataset of focal methods, demonstrating its effectiveness in diverse software engineering tasks. Section: Multi-Agent Collaboration. In this section, we discuss how AutoDev supports collaboration among multiple agents for tasks managed by the agent scheduler. During our evaluation, we focused on the human eval dataset simplicity and used a single GPT-4 agent for tasks. However, initial results show that collaborating with multiple agents can benefit more complex tasks. For instance, when an AI developer and AI reviewer work together to fix a complex bug, the AI reviewer could spot mistakes early and offer helpful suggestions before the code was validated. Our future plans include testing AutoDev in more intricate scenarios to enhance its performance through multi-agent collaboration. AutoDev allows AI agents to update on task progress or ask for human feedback using the talk and ask commands, respectively. Developers using AutoDev have found these commands useful for understanding the agent's intentions and plans. The ask command was added based on feedback from a developer during our pilot study who wanted to give input when agents seemed unsure about their next steps. We aim to further involve humans in the AutoDev loop, enabling users to interrupt agents and provide immediate feedback. In our pilot study, developers used AutoDev as a CLI command, with conversations visible in the VS Code IDE. Our future goal is to integrate AutoDev into IDEs to create a chatbot experience and include it in CI/CD pipelines and PR review platforms. This integration will allow developers to assign tasks to AutoDev, review results in a PR system, and streamline the software development process. Our work builds on existing research that applies AI to various software engineering tasks. We explore recent advancements and position AutoDev within this research landscape. The integration of AI, especially large language models, LLMs, in software engineering has made significant progress. Models like GPT-3, Instruct-GPT, and GPT-4 use the transformer architecture to understand and generate natural language and source code. These LLMs have large parameter sizes, enabling them to excel in diverse tasks. As software development evolves, incorporating cutting-edge technologies like LLMs becomes crucial for enhancing developer productivity. Using LLMs in IDEs has gained attention, with models like GPT 3.5, GPT-4, and Code Llama acting as intelligent programming assistants. AutoDev is a comprehensive framework for autonomous software engineering tasks in a secure environment, offering a versatile tools library for AI agents to perform tasks autonomously. Evaluating LLMs for software engineering tasks presents challenges, as traditional metrics may not capture essential programming aspects. Platforms like CodeXGlue provide a comprehensive evaluation for LLMs in software engineering, addressing these limitations. Our future work aims to assess AutoDev on more challenging datasets like those in the Copilot evaluation harness. While previous works have explored AI and software engineering, few have focused on AI-guided programming within IDE interactions. AutoDev draws inspiration from existing works like AutoGPT, LATS, and Reflection, adapting their ideas for software engineering tasks. AutoDev aims to bridge traditional software engineering practices with AI-driven automation, enabling collaborative efforts between developers and AI agents.